Hey guys, thank you for clicking on this video and welcome to episode 10 of my Arduino tutorials. In today's video, we'll be talking about the analog read command and what you can use it for. Without much further ado, let's get straight into the video. The analog read command handles up to 10 bits. That's 2 to the power 10. And 2 to the power 10 is 1024. 1024. So I want you to think about it this way. We have 1024 boxes, and then we're writing a number on a sheet of paper and placing it in each of the boxes. If you start from 0, the last number will be 1023 rather than 1024. The 1024th box would be 1023 because we start from 0. So we're handling 1024 values from 0 to 1023. And then that's the range for the analog read. The analog read is used to read analog values from the analog pins. We'll talk more about it. So then even if you don't understand certain things, you will in the course of the video. That's what this video is for. So it's nothing too complicated. You just connect whatever you want to read, or a sensor, or maybe just want to read voltage. Like we'll be doing this, we'll be reading voltage using the analog pins and the analog read command. You just connect whatever you want to the analog pins, and then it's not too complicated. These pins right here, the analog in A0, A1, go, and all these pins, these are your analog pins. You can use them to read analog values. You just plug it the Arduino to your PC and you can read it through a serial monitor. That will be using it in this video to read voltage. We connect it to our Arduino circuit, and then we'll be able to read the voltage flowing through the circuit. So, like I was saying, we'll be using those analog pins in this video. We'll be reading voltage. And then remember, it's working with 1024 values. So rather than 1 to 5 volts, it's working with 0 to 1024 volts. It's using those values to represent the voltage. So we even have to scale it down, which we'll speak about. I'll explain everything. So you stick with me. Alright, here's how you draw the diagram for the circuit. We have the 5 volts. Let me show you guys. This is the 5 volts with a battery connected to the resistor, which is 220 ohms, connected to the LED, which is connected back to ground. I have to put a ground there. Give me a sec. We have our ground, GND. Pardon my handwriting. Alright, that's our ground. So we have all of it linked together. And over here we have this connection to the analog pin. I showed you guys the analog pins on the Arduino board. And this is connected to it. And you can see it's at the end of the resistor. I didn't connect it anywhere else. If I had connected it over here, I would have been reading 5 volts, but I want to read the voltage drop across this resistor, so I connect this at the end. Alright, let's continue. I've already built my circuit. It follows the circuit diagram we drew. The red pin is from 5 volts to the resistor to the longer leg of the LED, and with the shorter leg connected all the way to ground. So I've already built the circuit. Let me show you how you can connect to the analog pin. These are your analog pins. These are your analog pins. You can connect to any one of them. I'll just connect. I'm using a yellow jumper wire. I'll just connect to pin A0. You can use any of them. I'm connecting from A0 all the way to the end. I really hope you guys can see it. To where the resistor, to the pin, the end of the resistor is connected to. It's in the same pin as the end of the resistor and the longer leg of the LED. They are in the same pin. If I connected it to this pin right here, I'll read 5 volts because 5 volts comes directly from the Arduino. But I want to read the voltage across the resistor. So then I connect it in the at the end of the resistor so I can read the voltage across it. Alright, open up your Arduino and make sure your Arduino is connected to it. Make sure you've connected the Arduino board to it. Now, in the void setup, we make sure we've set everything up. Wait, let me make the variable for the pin I'm connected to. And I'm connected to pin A0, right? I'll make the variable pin and then set it to A0. Don't forget the semicolon. We come back into the void setup, pin mode, working with A0. And this time out, it's an input, not an output. Normally, the Arduino is outputting through the LED. It's outputting light to the LED, or maybe if you connected a buzzer, to be outputting sound. But this time, we're inputting the voltage. We are the ones reading the voltage from the Arduino, from the LED. So then we're just reading it. I don't really know how to put it properly, but think of it this way. When we are outputting, the Arduino is giving out information. It's giving out, whether it's in the form of light or sound, audio or whatever, it's outputting information. When it's an input, the Arduino is taking in information. Like this time, it's taking in the information on the voltage we are seeing. Alright, so just set it on input. Hope you can at least get the idea of what I mean. Now in the void loop, we use the analog read. Now with the analog read, you have to read a certain pin into a variable. Let me set up a variable. We have to read a certain pin into a variable. Let me name the variable value. I'm not going to connect the variable to any pin. I'm just setting it up like this. So I don't bring anything, I don't connect it to any pin. Now, we're reading into this variable, and the way we do that is like this. I mention the variable value equal to, and then we write the code, analog read. What do I do? Read. Bracket open. We're reading pin, that's A0. Pin is, the variable pin is connected to A0. So we're reading pin. So we're reading pin, and the value we get from pin is going to be stored in this variable called value. That's the variable we've created. So whatever we read from here is going to be stored in here. Forgot to set up the serial monitor, otherwise we wouldn't be able to see the value we want. Set up the serial monitor. Get back here and then serial dot print ln. We're going to print value. We're going to print value. That's why it's important to read it into a certain variable. So now we put the variable here, and whatever is being read into it, whatever value it is, will be printed to the serial monitor. Let me put in a delay, otherwise it will be too fast. I'll call the delay wait. Let me go and set it up in here. Okay. Wait. Let me make it 0.4 seconds. That's 400 milliseconds. I think that would be enough. Alright, with that I can upload. Alright, let's open the serial monitor and see what's happening. I don't see anything. Let me close it and open it again. Serial monitor. Okay, alright. So now we are reading 582. But what does that even mean? Now here is the thing. Remember I mentioned it's working with 10 bits. So 1024 values. So then it's from 0 to 1020. So and this is a value on that scale. So then we'll have to scale it down to what we want. And then we want it to be between 1 to 5 volts, right? Because the Arduino is given out 5 volts total. So we want it to be on that scale, 1 to 5 volts. So then if it's somewhere in between that, we'll be able to actually understand that better rather than over here where it's 100 and something. We don't even know what that means. So we'll need to scale it down. And this is where you find out school is actually important, because we'll be using a certain concept they teach in school. If you don't know it, I'll still explain it so you can still understand. To be able to scale it down to a range we want from 1 to 5 rather than from 0 to 1023, we'll have to plot a graph. We're not plotting a graph, we'll use a graph. We'll find the slope. That will help us find a certain, should I say, formula which we can use to scale it down. It's nothing complicated, so don't worry too much. So I've already drawn it. Put a 0 here, make here y, make here x. The variable we created for is value. So let's put that here. That's the current value, 0 to, it's 0 to 1023. 1023. And then we want to scale it down to the normal voltage, 0 to 5 volts. We want to scale it down to our normal voltage, but right now it's from 0 to 1023. Let me draw a line and we can find the slope of the line. Now, here, let's take 2 points of the line. Let's take 2 points. Over here, we have 0 for the y-axis and 0 for the x-axis. So 0, 0. And over here, 0, 10, 23 for the x, and then 5. This point is plots at 10, 23 and 5. 10, 23 on our x-axis, 5 on our y-axis. That's this point right here. This point right here. That's where it's plotting. And then this here is 0, 0. So these 2 points, we take these 2 points and we use them to find gradient 0, 0, and then 10, 23, 5. All right. So we have to find the gradient of the line. We can use this formula y2 minus y1 over x2 minus x1. Y2 is 5. Y1 is 0. X2 is 1023 minus x1 is 0. So then our gradient will be 5. Hope you can see 5 over 1023. Yep, this is our gradient. Now we'll use this gradient to find the equation of the line. I know it's going far, but to find the equation of the line, the formula we'll be using is, hope you guys can see, y minus y1 is equal to m, which represents the gradient, into brackets x minus x1. Now, y is voltage. So I want to substitute the actual values into it. Remember, the y-axis is voltage, the x-axis is value. So I want to substitute it into the formula. Y is voltage minus y1. Y1 is, what was y1? 0 is equal to m. Remember the gradient, 5 over 1023. X is value, the value we are getting, minus x1. X1 was 0. Put 0 there. Hope you guys can see. All right. So now we will just work it out. We have, let me push this up a bit. We have voltage. We take this out, it doesn't do anything. Equal to 5 over 1023 times a value. because we take this out, it just looks like this and it multiplies. So this is the formula we'll be using to scale it down. This is what we use to scale it down. So now we go back to the code and then we put this value in the code. All right, so we come back to our code here and we input the formula. Remember, the formula was voltage, which I'll have to now create a variable for voltage. Voltage is there. We want to scale it down to the actual voltage level. It's 1 to 5, right? Let me put this here. That's what this is. So how do we get this? How do we scale it down to this right here? How do we get this value? The actual voltage. So voltage is going to be equal to, it was 5 divided slash 1023, and I want to set them up as floats. I want to get accurate values, very accurate values. So 5 divided by 1023 multiplied by, to multiply, use this sign right here, the asterisk, and we multiply it by value. Multiplied by the value we'll be reading, this value. The value will be reading from the analog pen. We multiply it by that. All right, and then we end it with a semicolon. So this is supposed to produce voltage. So over here, I'll change the value we want to print out to voltage. So let's see if it prints out the actual voltage from 1 to 5 on that scale we made. Let's see if the calculations were correct. Uploading. Okay. All right. So open my serial monitor. Don't change anything. Let me open it again. All right. So now it's printing out 2. But this is not, I want it to be more accurate. So I'll change the end here to float. So we can get it to the decimals. I don't want it to run everything for me. All right, now it's giving me the actual decimal. So I get it very accurately. 2.85. That's the amount of that's the voltage drop. So now that we know how much it's dropped, we can calculate the amount, the exact voltage getting to the LED. We know we are supplying 5 volts. So if I are supplying 5 volts and the 5 volts gets dropped by 2.85, let's do the calculations. Now we can get the voltage supplied to the LED by subtracting the voltage dropped across the resistor from the total voltage, which was 5 volts. So the total voltage, hope you guys can see. The total voltage subtracted from, no, minus the voltage drop across the resistor. The voltage dropped across the resistor will give us the voltage actually being supplied to the LED, so we can know how much is actually going into the LED. So the voltage, the total voltage is 5 volts, and while subtracting that from the voltage, that was around 2.85. So now we can get the voltage actually being supplied to the LED, and that would be 2.15, I believe. So 2.15 volts. Yeah, so I believe the voltage actually being supplied, not I believe, I know the voltage actually being supplied to the LED is 2.15 volts. That's it. Thank you for watching this video to the end. I'll leave a link in the description to my website. If you are already watching on my website, just scroll downwards, you will see the notes I leave to help you understand everything better. I'll see you guys in the next video.